So hello future achievers, today we are going to start our chapter, some basic concept of chemistry. Okay, so before we start this chapter particularly, right, there are some things, some formulas, some understandings we need to keep in mind. Okay, so we'll be starting out with very basic. Yes, we are going to go a little bit theoretical in this lecture only. Okay, but yeah, just keep up. We can actually proceed with some practical problems. Okay, and you can expect a numerical problem in the next chapter, next lecture. Okay, so let's start. So our chapter is some basics concept of chemistry. Okay, we are starting chemistry, right? We need to understand every basic detail of it, every basic detail, right? Let's start. Okay, so first of all, we need to understand one thing, right? The first thing we need to understand is classification of matter. Okay, by the way, don't mind about this. Classification of matter. How can we classify elements or like matter? Okay, first of all, the first question that should arise in your mind is what is matter? Okay, have you studied this? What is matter? Can you answer? Okay, it is recording, but yeah, you need to keep in mind you are sitting in a lecture, you are in a class. Okay, so whenever I ask some questions, make sure to answer them. Okay, so think about this. What is a matter? It's everything lying around us. Okay, a chair is a matter. Okay, the screen is form of matter. Me, you, and everything is formed of matter. So what is matter? Something which occupies space and have mass. Okay, it's a very simple definition that we have studied in our 9th class or 10th grade. Okay, we have studied about this definition. Okay, so first of all, the matter can be classified, okay, into two aspects. First is the physical classification of the matter, and the second is the chemical classification of matter. Okay, so physical classification and chemical classification. First, let's study about physical classification. Okay, so we are going to classify matters based upon their physical properties. What do I mean by those physical properties? How they look like, how they feel, okay, what is their form. We are going to classify matter based upon these physical phenomena, physical properties. Okay, so physical classification. The first classification, as we can see, is what? It is solid. As we know, physical classification: solid, liquid, gas. That's what we have studied. Yes, this lecture is going to be very easy. Okay, you don't have to think something out of the box. Okay, and you can expect in this series, you can expect numerical problems. Every formula I will give you, and not just formulas, the correct understanding of the chapter I will tell you. Okay, so first, solid. Which things you call as solid? What do you think? Solid, it's something, which has a defined shape. For an example, can I call this thing as solid? This shirt, can I call this solid? Yes, this is solid because the thing that is made, it is made of, it cannot change the shape, it cannot flow. Okay, solid is something which is definite shape and definite volume. This is very easy, I know, but just keep up with me. We have to actually go through this one. Okay, so solid is something which is definite shape and definite volume. Okay, the volume may change depending upon the pressure, but yeah, it does have a shape and a volume, and that is classified as solid. Okay, if you go in detail, there are other two states of matter. You might have heard about them in the like the 9th grade book. You will have heard about those extra two states of matter, but we are not going to discuss it today, not tomorrow. Okay, so second state is liquid. Like, how can you define liquid? What is a liquid? I know the definition is written, you just avoid it for once and try to answer by your own. What is a liquid? Okay, sir, liquid is something which can flow, right? Yes? Yes. Liquid is something which can flow. Okay, we talked about definite shape. Does liquid has some definite shape? I don't think so. So liquid doesn't have definite shape, and plus one more thing. Okay, it can also flow. Yes, liquid can flow. Obviously, we know this, but this is a property we need to know. So it doesn't have a specific shape, okay, and a specific volume. Got it? I hope I am clear, right? As we can see, gas. gas is also, you know, somewhat similar to a liquid, but obviously it doesn't have a very is having very lesser density. Okay, so gas is having no fixed shape and volume. So even the volume is not fixed and even the shape is not fixed. Okay, so once again revise. Solid is definite shape, definite volume. Okay, not specific shape but definite volume. Okay, so shape is there, volume is there, right? Now shape is not there but volume is there. Now in this, shape is also not present and volume is also not present. I hope you can remember these things just by two facts. Should you move ahead? It's very easy. Okay, if you want to save up your time and the lecture is looking like to be very easy, just run it on 2x. It will be very easy for you. Okay, at least just don't leave anything. Okay, now let's go on to the next slide. Okay, and let's discuss about chemical classification. Okay, how we are going to chemically classify matter. Okay, if something is in front of me, okay, and I need to classify it, I might say it is solid, liquid and gas, but that is physical classification, right? That is called physical classification. But if I want to classify matter based upon the chemical properties, how am I going to do it? Chemical classification. Think about this. First, mixture and pure substance. For an example, okay, mixture and pure substance. From the name, it is itself clear, right? One is a mixture and one is a pure substance. Okay, is there anything else to explain in this very easy topic? No, it's not. Okay, so mixture is having a variable composition. What does it mean by variable composition? It means the composition is changing. If you see any other thing, like you're making food, right? Okay, that food is a mixture of different vegetables, different spices, right? That food, their chemical classification is known as a mixture. Got it? And pure substance. For an example, you're eating a single fruit, right? Okay, that single fruit can be just represented as a pure substance. Okay, that is not an exact example. Okay, this is just you know, informative example, not an exact example. So a pure substance has a fixed composition. It means the composition of the substance is fixed, right? For an example, if I am taking hydrogen gas, okay, I have molecules of hydrogen gas, okay, a lot of molecules. Then this is a pure substance, right? This is what? A pure substance. Okay. Now, can we change colors, right? Okay, we can't. Now, this is called pure substance. Okay. And what is mixture? You mix two things. You mix two chemicals, you get a mixture. For an example, if you are mixing hydrogen, then what do you get? You obviously get water. Okay, but we are not doing the reaction. To make this reaction happen, we have to pass electricity through it. Okay, but anyways, this is a mixture. You have a hydrogen gas and oxygen gas. The chemical composition is not just made of one compound. It is made up of multiple compounds, not just two, more than two. So it has more than two substances in it. Okay, and pure substances just has one type of substance. I hope I am clear with this. Okay, it's nothing difficult. Let's go on to the next slide. Okay, so the classification of matter, we discussed the chemical classification. One we discussed as the mixture and one we discussed as a pure substance. Now we have further classification in itself. Okay, let's study about them. So chemical classification, first is the mixture and the another one is pure substance, as we studied in the previous slide. Okay, so mixture and pure substance. Let's first understand about the pure substance. I think it should be given over here so that we can proceed with in a respective manner. So pure substance, we have the pure substance as the element. Now these two definitions might look very easy for you. Okay, it's element, I have studied about it, compound I have studied about it. But can you define what is an element? What is a compound? Element, compound. Pause the video right now and then think about this. How can you define an element and how can you define a compound? Okay, compound is formed of different atoms. Okay, it is formed of what? Oh, sorry. Compound is formed of different atoms. Okay. Can you name one compound? Okay, just give it a try. And element is formed of same type of atom. Same type. Okay. Just one type of single atom. It is not fixed that the atom should be just a single one. Okay. If we take hydrogen, okay, that is an atom. Okay. If we take H2, okay, because this is how hydrogen exists in nature. We don't, okay, it doesn't exist in nature, right? But yeah, H2 is the form exists for the hydrogen. It doesn't exist in just H form. Hydrogen is an atom. But when you talk about H2, that is an element. I hope it's clear, right? H2 is an element. And let's think about O2. What do you think? O2 is an element or a compound or an atom? No. O2 is element. Same type of atom. Maybe greater than 2, it is fine. Okay. Carbon. Although carbon exists as single one, it doesn't need anybody. Okay. It has different structure. It may exist as diamond, graphite. But yeah, carbon is also an element. Okay. Same type of atom. Whether it doesn't matter however number of atoms are there, 2, 3, 4, 5, single one, still that is an element. Now what about a compound? Can you define me what is a compound? Pause the video, tell me the definition of a compound, okay, if you have understanding, not just definition, okay. See, what is a compound? A compound is a mixture of two things, right, two or more of the elements, two or more of the atoms. Okay, it is not just a single form, okay, like H2, O2, C2, although C2 doesn't exist, right. So, compound is a mixture of two elements or more than two elements. For an example, we have H2 element, we have O2 element, okay. We have H2 as an element, okay, and we have O2 as an element, and what do we get? We get water, okay. The equation is not balanced, I know, but we get water. Water is what? It is a compound, okay. So, compound is something which is formed of two or more types of atoms, okay. Any other chemical you can name me? Can you name me any other chemical? Acid. Do you know H2SO4? I hope you know this acid. Do you know the another one acid? HCl, okay, maybe NaOH. What are these? Are these compounds or the elements? What are these? H2SO4, NaOH, HCl. Yes, these are compounds. I hope now you are clear with the understanding of element and compound. Okay, this lecture is easy. I know it is very a starting lecture. Okay. Now mixture. We have two types of mixture: homogeneous mixture and think about it for a second. What is a homogeneous mixture? Heterogeneous mixture. Homogeneous, from the name I think you can imagine that the name is itself clearing out the definition, that homogeneous, everything is like what do you say, same consistency, everything is having the same consistency. For an example, if I ask you, okay, if I mix in water, I mix some salt, okay, and I stir it up. Now can you see salt? No, you cannot see salt, right? You can just see water, okay. It might be that due to some impurities the water will be a little unclear, but yeah, can you notice any other fragments of salts in them? No, right? So that mixture where you cannot define two different particles, okay, you mix one particle and you mix two particles, okay. When you mix those particles, one can be solute and another is solvent, okay. Always remember, in a homogeneous mixture, one is a solute, another one is a solvent. Remember it, okay. It is very thick, I just need to bit down it better. Okay, so one is a solute and another one is a solvent, okay. If we are studying about solute and solvent, try to make notes. If you are making notes, try to make it with me, Okay, you might get this PDF, but yeah, making notes is far better. Okay, you just watch the lecture in one go, and then you form the notes in the second time when you are watching things. This way your revision will be twice, plus you have notes, so it will be revision in the 3 time. Okay, so solute and solvent. 1 and 2, homogeneous mixture, not this one, homogeneous mixture. Okay, a homogeneous mixture is made up of solute and it is made up of a solvent. Okay, homogeneous mixture is also of many types. Maybe liquid homogeneous mixture, maybe a gaseous homogeneous mixture, maybe a solid homogeneous mixture. Okay, or just subjective things. Okay, these are just a definition type of thing. When it comes to NEET, they are not going to ask you these definition type of things, but understanding these things are more important than going on to the formulas. If you are not understanding this, you won't be able to do it. Okay, now solute and solvent. Okay, basically solute is like, you know, it is in smaller quantity. Okay, it is in smaller quantity, and this solvent is always in a larger quantity. Solvent is used to be in larger quantity, right? Okay, homogeneous mixture, it is made of solute and a solvent. When we see a homogeneous mixture, we cannot see the different particles, we cannot see discrete particles in the solution. Okay, it is just like somebody mixing some water in the, what do you say, in milk. Okay, you are not able to define, okay, this is the water particle, this is the milk particle. Okay, so you are not able to define it. That is a homogeneous mixture. Well, if you call this, that is a colloidal solution if you go in detail, but yeah, we are not going in detail right now. Now another is heterogeneous mixture. So I hope you have studied this in the grade 9, right? Grade 9 we do study this homogeneous mixture, heterogeneous mixture, and one is also there in additional colloidal solution. Right? I hope you have heard of it. Colloidal solution. Okay, and in homogeneous mixture, the solute particles are very lesser in size and also in quantity as compared to the solvent. So they quickly dissolve in it. You are not able to distinguish it. When it comes to heterogeneous mixture, what can you expect? I hope you have noted it down, right? Okay. Now heterogeneous mixture is a type of mixture in which the two elements are there. Okay, and you can distinguish one element with the another one. Now suppose I have mixed it, right? Still you can define this is the particle number A and this is the particle number B. Suppose you are mixing particle number A with the particle number B. Okay, and the mixture can be homogeneous and can be heterogeneous. Now if the mixtures are like homogeneous and the heterogeneous, you will be able to find the difference in them. How? When the mixture is homogeneous, you will not be able to define. The mixture will look something like this. I will draw it. It will look very consistent. You won't see single discrete particles floating around in the mixture. But when it comes to heterogeneous mixture, okay, yeah, when it comes to heterogeneous mixture, when you make a mixture of it, the particles will be, you will be able to see the particles. Okay. For an example, sometimes when you are trying to mix dirt in water, you sometimes see that, okay, I can see the dirt particles. Okay, those are heterogeneous mixture. Okay, so in the homogeneous mixture, the size of the solute is like very smaller, whereas the heterogeneous mixture, the size of solute is much larger. Okay, hence it is not able to dissolve in the solution, and you are able to see it as a discrete particles. Is there any confusion in this slide? Okay, let's revise one time. Chemical classification: mixture and pure substance. Pure substance is either element or compound, or mixture is either homogeneous or heterogeneous. Is it clear? You are not going to come back on this particular topic once you totally understand this. Okay, let's move ahead, guys. Okay, I need to cancel this first. Okay, so let's study about some of the properties of matter. We studied about the classification. One classification is the physical property, another is the chemical property classification. Physical, solid, liquid, gas. Chemical is what? Revise with me. Chemical is what? First is mixture, another is pure substance. Mixture is hetero and homo. Pure substance is what? Element and compound. This is how you need to create the mind map. Okay, you need to do this if you want to pass your NEET. Okay, you have to be good at imagining things. Stick with me, I'll tell you everything. Okay, now properties of matter. properties of matter. We are going to study some of the properties of matter, okay, and the properties we are going to study is physical properties and chemical properties, okay. Now physical properties and chemical properties, as from the name I think it is clear what is a physical property and what is a chemical property. Now let's study what is a physical property. Can you define what is a physical property? Let's see the definition itself, okay. Properties which can be measured or observed without changing the identity of the composition of the substance, okay, blah blah blah, too much definition. It is just saying that it is something that you can measure without actually changing what the substance is. So if I like think about salt, okay, right, some salt or maybe this chair or something else, right, without changing the composition of that chair, without changing the composition of that salt, I can define those quantities. Those are physical properties, okay. And about chemical properties, properties which can be measured only by some means of chemical reaction, okay. Only some means of chemical reaction can tell you about chemical properties. Of the physical properties, okay, can you just name me what are some physical properties? If I show you something, can you define me something about it? If I show you a chair, what can you say about it? First, sir, the color is of this thing, and this material can melt at this point, this material has this boiling point, I have used this density, okay. These kinds of things you can define about some physical matter, okay. You can define their color, their melting point, their boiling point, their mass, okay, and their density. All of these things are physical properties, okay. Can you just name me some of the chemical properties? What are the chemical properties? Okay, chemical properties can only be found out if you are using if you are just comparing it, if you are just doing some chemical reaction, okay. So you are changing the property, changing the composition of the material, okay, to test it out what is happening. So what can you test about it? You can check acidity, you can check basicity, you can check combustibility, okay. All of these things are chemical properties of a matter. These things are the physical properties of a matter. I hope I am understandable. These are very basic parts, okay. This is the very basic component of the chapter, but we need to go through this if we want to understand some tough chapters like ionic equilibrium, electrochemistry. There are a lot of chapters, okay, which are kind of you say tough if you are not able to understand this. This is the keyword, okay. You have to understand the keyword, because if I in the further chapter, if I start using this keyword, you will not be able to find, okay, you will not be able to understand, okay. The basic thing why people sometimes miss, they are not able to do some tough problems because they do not know some basic concepts. They have done very important problems and all those difficult things, but their very basic concepts are kind of weak. That's why they are not able to do some tough problems. Let's go to the next slide. So as we talked about physical properties, we also need to know how can we measure those physical properties, okay. So physical properties can be measured by like a number, okay, a number. Wait. Oh. Okay, So physical properties, how can you measure a physical property? First of all, you need a unit and you need a number. If I am measuring weight, what do I say? Do I say 60 or 60 kg? If I am measuring a length, what do I say? Do I say 5 meter or just 5? Okay, I need a numerical quantity and a unit with which I am going to multiply that quantity to represent it. For an example, if I say this monitor or this floor is 5 times the length of my palm, so that 5 times is the numerical aspect, okay, and this what do you call it, this palm, okay, this is a unit. I hope I am understandable, okay. Now, so you need a number and you need a unit, okay, you need a unit. 6 times of what? 5 times of what? So 6 times of meter, 5 times of centimeter, those centimeter, meter. This is a unit in which the length is measured, okay, and these units are defined. So this is unit in which the length is measured, okay. I hope I am understandable. You need a number and you need a unit to tell a physical properties. Here in this case, the physical property that we are going to talk about is length, okay. This is the physical property we are going to talk about. Suppose length, how we are going to measure it? I need a number that is 6 and I need a unit that is meter. This meter can be also represented in centimeter, mm, depending upon the requirement, okay. So any quantitative observation or measurement such as length, area, volume, etc. is represented by a number followed by a unit, okay. So if you are representing anything, any physical property, you need a number, okay, a number and a unit, okay, in which it is measured, a unit in which it is measured, okay. I think it is clear. And also this part, okay, the further part which I am going to teach, unit, type of fundamental units and all those things. I hope you would have studied this in physics, okay, sorry. So you would have studied this in physics, and I expect you to might know something about this, but even if you don't know, I am here to explain it, okay. But majorly this part is actually done in physics. Okay, so let's study about unit, okay, how we are going to understand the unit. Now unit is, oh sorry, yeah. So what is a unit? Can you define me? You would have studied this in physics, right? Or if you didn't have studied this in physics, you can just tell me what is a meter, what is a kg, what is something, okay. It is a fixed quantity in which a particular physical quantity is being measured, okay. So if I say about meter, what is a meter? A meter is a length, okay, a fixed amount of length, okay, which is used to measure length. I hope it's a little bit confusion, okay. A unit is the standard of reference chosen to measure or express any physical quantity. So it is a standard or maybe a reference which is used to measure any physical quantity, okay. Earlier when we didn't have these fixed quantities like kg or milligram, meters and all these things, what we used to do, we had some rough values, okay. For an example, say somebody, if there is a world in which there is no unit, okay, how do you measure a cup, like how do you measure it, okay, or like volume. So this might be some fixed amount of volume, okay, some cup, okay, in which somebody will be measuring things, okay. And say if he is selling rupees 50, okay, for one cup, okay, for 3 cups, the 3 times of the volume of the same cup, okay. So he is using the cup as a what, as a reference, okay. He is using the cup as a reference, and that reference is known as unit, that is known as unit, okay. So SI system has 7 base units. So there are some of the fundamental units that we need to just give a look, okay. We are not going to go in detail of these things, I will tell you every definition about it, but yeah, we are not going to go in detail, okay, because this is what we do in physics, this is chemistry, okay. We need to understand our part, okay. You can do physics, okay. Physics is also going on in this YouTube channel, we can go through those lectures and let me know, okay. So SI system has 7 base units pertaining to the 7 fundamental scientific quantities, okay. So some basic physical quantities, tell me some basic physical quantities, sir. Mass, length, time, okay, these 3 you have heard of, right, okay. These are like basic quantities. These quantities, over these 7 quantities, other quantities are being formed. Now would you like to know what are those physical quantities, okay. So here in front of you guys you have those 7 physical quantities, base physical quantity, okay. So first of all, we have, can I just go choose any other color? I hope this one's like okay. Yeah, this one's okay. This one is okay. I hope it is clear, right? Let me just check if this color is clear. Yeah, this color is clear, okay. Now we have base physical quantities, okay. So mass, we have heard of it, okay. We represent it as m, okay. So mass, length, time. You already know what is mass, what is length, what is time, okay. No need to. Now what is electric current, okay. It is a unit used to represent how much current is flowing in a wire. That's it, okay. I'm just going to give a simple short definition about everything, okay. Thermodynamic temperature, okay, it's very just word, you just need to measure temperature, okay. This quantity is just a second. Yeah, okay. So thermodynamic temperature, and then we have amount of substance, okay. Amount of substance is like mole. Like sir, amount of substance can be defined by mass. Why are you using moles? What is difference in moles and amount of substance? Okay, if I am trying to find what is the amount of substance, I can tell this is 13 kg of substance, this is 15 kg of the substance. You are defining the weight of the substance, okay, sorry, the mass, okay. You are not telling how much things are in there, okay. There is a difference between these quantities, the mass and the amount of substance, okay. Now then luminous intensity. What is luminous intensity? Luminous, what do you know? The light itself, okay. How much this light is it, okay, how much it is glowing, the intensity of the light, okay. So that is defined by the luminous intensity. These are the 7 base quantities we have, okay, in which other quantities are derived, okay. So for an example, if we talk about force, force is what? What is force? Mass into acceleration, right? So now again, what is acceleration? Acceleration is a change in velocity per unit time. Again, what is velocity? Velocity. Yeah, velocity is length upon time. So again, it will be t square. See, mass, length, time. Mass, length, and time. Any quantity is going to be represented in terms of these 7 fundamental quantities. Okay, let's see how they represent. Length is represented in terms of L, mass represented in terms of M, and time is represented in terms of T. Okay, electric current is represented as I, thermodynamic temperature as T, and amount of substance is N. N is what we are going to study in this whole chapter. Okay, this is one of the most important and sometimes one of the most confusing things when it comes to teaching it. Okay, not teaching it, sorry, understanding it. Okay, it's very easy for me to teach it. Now luminous intensity IV, okay, and just you can represent it as I only. Okay, so units are length measured in meters. This is the SI unit. Okay, it is a fixed unit. You cannot tell me centimeters or mm. Those are like different units. But the SI defined unit is meter. You have to tell me the like definition or maybe a length in meters. Okay, the fixed type of unit. For mass it is kilogram, for time second, for current obviously you would have heard about this in 10th class or 10th grade. You would have heard that ampere, 2 ampere, 3 ampere is the current, and temperature is measured in kelvins. You would have heard about Celsius, but this is not the SI unit. SI unit for measuring the temperature is Kelvin. Most of the time in chemistry, if you are trying to understand something, okay, it is if it's temperature, right? In that case, you have to measure that thing in terms of Kelvin, not Celsius, okay, and moles, okay. Now this I is represented in terms of candela. So the signs are M, kg, seconds S, ampere A, Kelvin K, moles MOL, candela CD. I hope you got it. Okay. This is about some of the basic fundamental quantities. Is it okay? I hope you can take a screenshot if you want to. Right? Done. Well, you will get this PDF, do not worry about this. You will get this PDF in the comment section. You can go and download over it, and otherwise if it's not in the comment section, you can see it's very easy. Okay. Okay, the international system of units. What is the international system of units? So we have derived unit. We had fundamental units and then we have derived units. What are derived units? This force, torque, energy, and what else? Speed, acceleration. What else? Any other physical quantity you can represent me? Yeah, frequency. All these physical quantities are derived quantities because they can be ultimately represented in terms of the fundamental quantities. Okay, got it? Fundamental units they can be represented. For example, force can be represented as this ml t minus 2. Okay, energy can be represented as ml square t minus 2. Okay, I hope you understand this. Okay, this is derived quantities. These are not fundamental. Derived quantities are represented in terms of fundamental quantities, mass, length, time, mass, length, time. Okay, and other quantities are there. For example, charge is also a derived quantity. Charge is represented in terms of current into time, A into T. Okay, derived quantity represented in terms of ampere and temperature. Got it? Now example is unit of area is meter square and unit of density is kg per meter cube. Okay, this is some example. Let's go on to the next slide. So let's study what is mass and a weight. Okay, mass is like the amount of substance. Okay, it is just the amount of matter. Okay, so mass of a substance is the amount of matter, okay, present in it. While we weight is the force exerted by the gravity. Mass, amount of substance, and weight is the force exerted by that mass, okay, because of gravity. As a unit of mass is kilogram. Got it? These are just easy things, okay. No need to go in detail about this thing because it's chemistry and not physics, okay. Sometimes I get confused how to handle this thing. Now we have volume. What is the volume? Volume is the amount of space occupied by a substance. It has a unit of length cube. Okay, we are measuring length into length into length. That is length cube. Okay, this is what fundamental quantity. This is what derived quantity. Okay, so in SI system the volume has a unit of what? Meter cube. Okay, got it? The next quantity we have volume of 1 unit. Okay. Also need to understand about the conversion. Okay, the definition is not important. The important thing is about conversion. How you are going to convert this thing. Okay. So volume of unit. How can you convert? So always remember this. This is one of the most important things that have just started now. Okay. Keep an eye on this thing. Okay. It's very important. 1 centimeter cube is 1 milliliter. Keep in mind. 1 milliliter is 1 centimeter cube. Okay, 1000 centimeter cube is 1000 ml, or you can say it is 1 liter. Okay, and 1000 centimeter cube is also known as 1 decimeter cube. What is 1 decimeter? Decimeter is 10 to the power minus 1. Okay, sorry, not 10 to the power minus 1. It is 1 decimeter cube. Okay, now if you do a cube. So 1 decimeter cube is 1000 centimeter cube and 1000 centimeter cube is what? 1000 ml. By the way, what is 1 meter cube? Okay, tell me what is 1 meter cube. Sir, 1 meter cube is 100 centimeter cube. Okay, and if it is 100 centimeter cube, what is it? Is 10 to the power 6 centimeter cube, and 10 to the power 3 centimeter cube we can define it as 10 to the power 3 into 1000 centimeter cube. Okay, now that is 1000. This centimeter cube is what? 1 liter. Okay, now it is 1000 liter. It means 1 meter cube is 1000 liter. The tanki, the water tanks you have on your roofs, on your houses. Okay, this is sometimes when you see 1 meter cube, it is 1 meter, 1 length, 1 breadth, 1 height. Got it? That's how you can see and imagine. Okay. This is important, okay, just note it down, it's very important. The conversions are important, maybe the definition of this thing is not important, but the conversion for chemistry is much more important. Now density, obviously density is like the mass per unit volume and its SI unit is kg per meter cube. The important thing is maybe the conversion, okay. Okay, temperature. So temperature is being measured in different quantities. First is like in the degree Celsius, okay. Yeah, so first is measured in a degree, second is measured in the Fahrenheit, third is the Kelvin, okay. Now there are three common scales to measure the temperature, which are Celsius, Fahrenheit and Kelvin. How do you convert from Celsius to Fahrenheit? Can you tell me? Yes, you just add in C you add just 273, okay, got it? I think something's wrong, just give me a second, okay, yeah. So 0 Kelvin is what? It is minus 273 degrees Celsius, okay, got it? It means if there is a temperature in Kelvin, you have to subtract minus 273 from it to get Celsius. It means Celsius is what? It means Celsius is what? Celsius plus 273 is Kelvin. Note this down. Celsius plus 273 is Kelvin, okay, got it? Now, and you can also convert, wait, you can also convert the Fahrenheit in the Celsius itself. So what? How can you convert? There is a formula, okay. Note this formula down. Temperature in Fahrenheit is equal to 9 by 5 times of C, okay, plus 32 degree. Got it? This is the formula you need to keep in mind, okay, to convert degree to a Fahrenheit temperature. I hope I am understandable, okay. Now the SI unit of the measurement is obviously the Kelvin one, okay, that is the SI unit that has been selected. If you want to measure, okay, the formula was written here, I didn't notice. Fahrenheit is equal to 9 by 5, C plus 32 and Kelvin is C plus 273.15, okay. In the further chapters you will understand what is the importance of this 273.15. Actually 273.15 Kelvin or 0.15 degrees, 0 degree Celsius or 273.15. This is the triple point of water. A triple point of the water is what? Is a form, is a temperature at which the water is available both in gas, liquid and the gaseous state also. This is why it is known as the triple point of the water, okay. I hope I am understandable, okay. Where are we right now? Okay. Okay. Yeah. Go on this one. Okay. So temperature can be measured in Kelvin and Celsius, okay. So the room temperature is 77 degree Fahrenheit. So room temperature is 77 degree Fahrenheit. Remember this room temperature, always remember room temperature. Whenever in the chemistry questions, when they ask you the room temperature, always say it is 25 degree Celsius. I hope I am understandable, okay. And that is 298 Kelvin. Whereas the boiling point is 212 degree Fahrenheit, 100 degree Celsius and 370 degree. And you can see the freezing point 22 degree Fahrenheit, 273.15. Okay, by the way, just imagine, just see one thing. The difference is 100, okay, between the freezing and the boiling point, and in the Celsius the difference is also 100, but in the Fahrenheit you will see the difference is what, around 180, right, 180, yeah, it is 180, okay. That's why to go from this to this you just need to add something, okay, but to go from this to this or to go from this to this you have to multiply something, okay, because the scales are not same, okay. Here the scaling is same, right, it is just that the initial value is starting from something else, got it. Okay, so don't worry, we are at the end of the session, okay. We just need to complete around, I guess, 2 slides only. The first slide is pressure. We need to measure the pressure. Pressure is what? It is the force per unit area. force is represented and is measured in the SI unit as Newton, and the area is meter square or pascals. Generally the ATM is the, in chemistry we used to define pressure in terms of ATM. What is ATM? Atmospheric pressure. The pressure you are feeling right now is the atmospheric pressure. You might not feel any extra pressure on you, sir, I am not feeling any pressure on myself, because the pressure was present since you were born, so you are not going to feel it, okay. If there is any increase or decrease in the pressure, then you will feel it, okay, because right now the pressure you are feeling is normal for you, okay. And some units of conversion you need to keep in mind, how to convert the pressure. This is unit conversion, okay. So always remember, 1 ATM is what? So 1 ATM is what? 1.01325 bar, approximated as 1 bar. So sometimes when remember 1 ATM is not equal to 1 bar, it is 1.01325 bar, okay, remember it, because most of the time they will be giving you problems based upon that numerical value. In NEET exams they are not asking you to calculate, they will not be supposing you to calculate everything, okay. And 1 ATM is what? 760 mm of Hg. It means this amount of pressure can support 760 mm height of mercury column, okay. And 1 ATM is also known as 760 torr, okay. It is also known as 760 torr or this 760 mm, it is same, mm of Hg or torr you call it, it is as same as that. 1 mm of Hg is equal to 1 mm of torr. These are some of the units how you are representing it, okay. Now 1 ATM is also equal to 1.01325 into 10 to the power 5 Newton per meter square, okay. It means 1.01325 Newton per meter square, okay. 1,1325 Newton meter per square, okay. It is represented in Pascal, which can be taken approximated equal to 10 to the power 5. So whenever you want to approximate, you can go like this, just 10 to the power 5 pascals, okay. Or if you want to be very precise about your calculation, you can be 1.01325 into 10 to the power 5, okay, Newton per meter square. You can write this. I hope I was understandable till this point of this lecture, and if you are here right now with me till the last point, okay, just go down and comment something that if you have any problem in this whole lecture, okay, you are not able to understand something, there is some problem going on, okay. If you want some guidance, something like that, if you have anything, just open up your heart and let me know in the comment section, okay. I try and do my best to answer it, okay. We are going to keep this part of the chapter end over here. The next part will be you will be receiving it in the next day, okay. In the next class you will be receiving that part of the chapter, and just we can finish up this lecture over here. And I just want to say you keep studying, okay. Results are not built in a single day, okay. So take care, see ya, bye bye, have a nice day, keep studying.